Yesterday we were working on give us the equations, and then we would have to give all of the information. So we would go through and give all of the different components. So today we're going to do the opposite. They're going to give me the information, and I'm going to create the equation. So let's look at example number 1. For example number 1, they give me foci and vertices. So I'm going to go ahead and plot those. All right, what is my major axis going to be, horizontal or vertical? Horizontal or vertical? Horizontal. How do I know?
Because the y value remains the same, the x value change.
Okay, so my vertices are both on a horizontal line, and my foci are both on a horizontal line. So remember, vertices are the endpoints of the major axis, so that tells me major is horizontal. And the foci are always on the major axis, so that tells me major is horizontal. They could have given me either one of those things. They didn't have to give me both, and I would have known. So I'm going to copy the equation there from higher up on the page for major axis is horizontal. So you'll notice that I really just need 3 things. I need the center, I need the A value, and the B value, and I'm done, right? Center, A, and B, all I need. So let's start with finding the center. If I have both of my vertices, where is the center?
In the middle.
In the middle, right. Or if I have both of my foci, where is the center? In the middle, right. So again, they could have given me either one of those things, and I could do the midpoint, and I could find my center. So my center, you might want to like hand draw it in first, and then just see where you are. So I just came over here and said, okay, halfway in between this vertex and this vertex is going to put me right here. Where am I? Oh, I'm at 2, 2. You also could literally calculate it out algebraically by saying, okay, if I go halfway in between 0 and 4, where am I? Or if I go halfway in between -1 and 5, where am I? You can calculate it as an actual mean, -1 plus 5 divided by 2. All right, so how do we find A? It's the distance from the center to what? The vertex, right. So if I go from my center, which is 2, 2, to my vertex, which is 4, 2, what's that distance? 2. So A is 2. B, I don't know. I don't have enough information about that. But I do have enough information for C, right? Because C is the distance from the center to a focus. So I could look at it and say, what's the distance between 2, 2 and 5, 2? Or what's the distance between 2, 2 and -1, 2? And so I'd be able to figure out that C was equal to 3. And then once I know A and C, then I can use Pythagorean Theorem, since that's the formula that equates A, B, and C with hyperbolas, to figure out what my B value is. So I'll get B squared is equal to 5. And so B would be the square root of 5. So we've already plugged in our center. That was HK. So we can come and plug in A. So since A was 2, then our denominator here, A squared, is going to be 4. And then over here, since B was the square root of 5, then our denominator, B squared, is going to be 5. And I'm done. That's all I have to do is just create the equation. All right, let's look at another one of those. Example number 4, they give me my vertices, and they give me the equations of the asymptotes. So let's start with the vertices. I have a vertex at 3, 1, and I have a vertex at 3, -5. So what's my major axis? Vertical, right, because those vertices are in a vertical line. So I'm going to copy the equation from up above, and again, I just need 3 things. I need HK, which is my center, and I need A and B, and I'm finished. All right, so if I go halfway in between my 2 vertices, where am I? I'm going to be at 3, -2, right? Because if I go halfway between -5 and +1, again, you can treat it exactly like a mean. Add them and divide by 2. So if you do -5 plus 1, that's -4, divided by 2 is -2. So 3, -2. So let's go ahead over here and let's plot that center on our graph, just so we can see what we're working with. And we also can slot it in here. We're putting the 3 in for H and the 2 in for K. Be careful that you don't put those in the reverse order. The 3 in for H being subtracted from X, and the 2 in for K being subtracted from Y. Okay, so A is the distance between the center and the vertex. So if my center was at -2 and my vertex is at -5, then that distance is going to be 3, right? So we could go ahead and say if 3, then 3 squared is going to give me a denominator of 9. Now, all I need is B, and I'll be finished. They didn't give me any information about C. Typically, they'll give me some information about the focus or something, and I can get C, and then I can use Pythagorean Theorem to come up for B. They didn't do that this time. This time, they gave me the equations for the asymptotes. Now, let's think about this for just a second. When my major axis is vertical, these are the equations for the asymptotes right here. Y is equal to K plus or minus A over B, X minus H. If you go through and you distribute that A over B to the X and you distribute it to the H, you can also, if you want to, move this K like out of our way back here to the end. So that's what I did. I moved the K to the end, and then I distributed the AB to everything in parentheses. So this is what I've got right here. If you'll notice, whether it's in that original form that we started with or in this form right here, you'll notice that the number in front of X is A over B. That's what I'm interested in, because I'm trying to find B, right? So in this equation, the thing that is that's grabbing my attention is this A over B, and that's the number in front of X. Even when I went through and I expanded it out, A over B is the number in front of X. And then back here, this would combine to be a constant. So if I look at the equations that they gave me Y is equal to 2x minus 8 and Y equals -2x plus 4. I am interested in the number that's in front of X. And what's in front of X is plus or minus 2. So if I match those up, then I can see that plus or minus 2 is going to be equal to plus or minus A over B. So I'm going to write that as an equation. 2 is equal to A over B. Now, I already know A, right? We've already found out that A was 3, so let's plug that in over here. I'm going to put 3 in the place of A. So now I have 3 over B is equal to 2. So all I need to do is just solve for B, right? So I'm going to multiply both sides by B. That would be 2B equals 3. And then divide. So B is equal to 3/2. All right, so if I know B is equal to 3/2, then let's come over here and let's put it into our equation. So we're going to have 3/2 squared, which would be 9/4. Now, there's nothing wrong with writing it with the 9/4 in the denominator, but a lot of times in the book, they're not going to leave a fraction inside of a fraction. Like they wouldn't like a fraction in the denominator. So dividing by 9/4 is the same thing as multiplying by the reciprocal 4/9. And so you may see them write it in that way. So either one of these is perfectly fine. Just, don't want you to write it this way and then think you've done it incorrectly because they write it this way. So now that we have talked about ellipses, hyperbolas, parabolas, and there's really nothing new for them to teach us about circles that we don't already know. So they're not going to readdress circles since we learned them earlier this year. So we're good with the 4 different conic sections. In the next section in 10.4, we're going to move into solving systems of equations that involve conic sections. And it'd be a really helpful thing when I get a system of 2 equations if I knew what in the world I was working with before I started. Like, is this a circle and a parabola that I'm trying to find the intersection of and that I'm trying to graph and that type of thing? And so over on page 719, before we leave this section, they give us a method that we can use to classify a general second degree conic equation. right? At the very beginning of the chapter, we mentioned that you could take a general second degree equation and you could form the different conic sections from that one equation. So, like down here, we have 4 different examples down here of the different conic sections. At this point, what we would have to do to figure out is that a circle, is an ellipse, or a hyperbola, what is it, is we would have to put it in standard form. Standard form, that means completing the square, right? Our favorite thing in the whole wide world, and for most of them we have to complete it twice to get it in standard form. So I'm going to do like a half a page of work to get it into standard form just to be able to figure out what it is that I'm working with. It would be nice if there was an easier way. And that's exactly what they give us on the top of page 719. They tell me that if you have an equation that is in this form, you can look at just the A and C values to determine which conic section it is. Now, what do they mean by A and C? A is the coefficient of x squared, and C is the coefficient of y squared. So they tell me if A and C are the same number, it's going to be a circle. If A times C is equal to 0, it's going to be a parabola. If A times C is greater than 0, and A is not equal to C, then it's going to be an ellipse. And if A times C is less than 0, then it's going to be a hyperbola. Now, one thing we want to stress about this, we're going to use this classification system only when we do not have a B term. If you'll notice in the equation that they gave us, it skips right from A to C. There is a B term, it's actually BXY, but we don't always use it. As a matter of fact, if you think about this week when we've been completing the square, we would get all the x terms together, get all the y terms together, move the constant to the other side. There was no xy term. We wouldn't have known what in the world to do with that, right? So this classification system is for when I do not have an xy term. Next week we'll be looking at what if I do have an xy term and how to classify with that. So we'll have 2 different structures for classification. So we want to stress here, this is when I do not have a B term. Now, if we're going to have 2 different systems, it's going to be easy to confuse them if we don't try and understand them and kind of make some logical connections with them. So let's just talk about where these guys come from, all right? If you're working with skip a circle for just a second, if you're working with a parabola, you never have an x squared and a y squared, right? In a parabola, it's either x equals y squared or y equals x squared, right? You're not going to have both x squared and y squared. So that means that either A or C is going to be 0. So if you take a number times 0, you always get 0, right? So that's why a parabola is going to have a product of 0. When you're working with an ellipse, remember in an ellipse we always add. So it doesn't matter if it's x squared plus y squared or y squared plus x squared, we're always adding. So that means that both of my coefficients, A and C, are both going to be positive. So when I multiply them, I'm always going to get a positive number. Whereas with a hyperbola, one's positive and one's negative, right? That's how we know which one is major with a hyperbola. The positive one is major. So if one of them's positive and one of them's negative, when you multiply A times C, you're always going to get a negative number, right? So pretty much makes sense up to this point, right? Are we good? All right, so let's go back and talk about a circle for just a second. It's easy to confuse an ellipse and a circle. Because if I looked at this and I said, okay, the leading coefficient is 1, the leading coefficient is 1, so A times C, 1 times 1, that would be 1. I would be tempted to say, okay, since A times C was a positive number, then this must be an ellipse. And so that's why they put this little disclaimer on here. If you get a positive answer, as long as A doesn't equal C, it's an ellipse. But if A does equal C, it's a circle. Here's why. All right, we know that this is a circle that has a center at 0, 0, nothing being subtracted from x, nothing being subtracted from y, and it's got a radius of 4. X minus h squared plus y minus k squared is equal to r squared, our equation that we learned earlier for a circle. But let's say that we didn't know that, and we looked at that, and we thought, ooh, that looks kind of like an ellipse. I probably ought to get that in standard form. So I'm going to divide everything by 16, so it's set equal to 1, so it's in standard form. And when you got to this point right here, you would say, nothing's being subtracted from x, nothing's being subtracted from y. I've got a center of 0, 0. And then you would come down here and say, 16 16 and 16. The bigger one is supposed to be the major axis, and they're the same size. I don't know which one is major. Well, it's really not going to matter which one I call A and which one I call B because it's the same number. So whether I call this one A squared or this one A squared, I'm still going to get A as 4. Whether I call this one B squared or this one B squared, I'm still going to get B as 4. And so when I draw that with a center of 0, 0, A and B both being 4, I realize, oh, this is a circle, because it's the same distance in all directions from that central point. So even if I didn't realize it from the very beginning, it would fall together that way. Circles and ellipses similar in that way then. It's just that with a circle, the coefficient of x squared and the coefficient of y squared are always going to be the same. So that if you divided them out by anything, you would always get the same denominators so that you would get a consistent distance from that center. So that's why down here they have this little addendum on here. Hey, if you get a positive number, it's an ellipse as long as A and C aren't equal to each other, because if they are equal to each other, you're looking at a circle. Okay, so hopefully we won't have any memorizing to do since we kind of reasoned that out. So look at the first one down here. For this first one, we have 4x squared minus 9x plus y minus 5 is equal to 0. So what's A?
4.
4. What is C?
0.
0, because I don't have a y squared term, right? So if there is no y squared, then y is 0. So if I multiply A times C, I get 0, right? And so if I get 0, what does that mean? This is a parabola. Now, you might have recognized that from the very beginning when you didn't have an x squared and a y squared. All right, look at the next one. What is A?
4.
4. What is C?
-1.
So when I multiply, I get a -4. What does that mean? Yes, this one is a hyperbola. How about the next one? What's A?
2.
2. What's C? 4. So when I multiply, I get a positive 8. So what is this?
Ellipse.
Ellipse, because I got a positive answer and A was not equal to C. A was 2 and C was 4. So yes, this is an ellipse. And for the last one, what's A? 2. And what's C? 2. So what's this one? A circle, right? Because A does equal C. So even if you multiply it and you get a positive number, you'd be like, oh, hang on, A does equal C, and that would point you back up here to the circle if you overlooked it. Okay? So again, that'll help us know what we're working with, particularly in the next section. Okay, so here is our homework for tonight on page 720.